Hi, everyone. I'm disappointed that I couldn't be there in person. I know I've missed out on a great program, and I'd like to thank the organizers for at least letting me share this talk with you. I know recordings aren't the best form factor, but I really appreciate being able to present this in some way. This is a rare event, FOSS4G, that brings together a broad audience from across the geospatial community. So, being at Overture Maps Foundation, the open source community is obviously particularly near and dear to my heart. So, this is really disappointing that I can't be there with you and talk to you all and see the great program that you've been experiencing this past couple days. But hopefully next year that will correct that. So today I want to talk a bit about open data rather than specifically about open source software because in my experience there's a fundamental difference that exists between them. And that's not always front and center when we talk about maturing the open data ecosystem. So there's been an enormous amount of work done in the last couple decades to start maturing open data in the way that we've seen open source software mature. This slide, there's a variety of things that I lay out here in what I'm calling the brief history of modern open data. So really, we're just talking about the last couple decades, and I'm sure I've left a lot off. But the idea really here is just to kind of show that over the last couple decades, it really has come front and center. Um, Definitions and licensing were really something that laid the foundation, both in terms of creating practical legal toolkits for sharing and defining what open means across content and data. But also, policy has been really important, harmonizing rules for things like reusing public sector information and strengthening the idea of open by default, which I think is really important. There's also been a number of efforts to set practical standards for open government data. And key there are things around operationalizing transparency and proactive data releasing, which wasn't always the case. And of course, on the research front, I think most people are familiar with FAIR and those principles that help bring interoperability and reusability into the mainstream. But I think one of the biggest things that happened is that we really saw countless use cases, real world use cases, particularly in emergency response, that spotlighted open data's role in being able to make good or better decisions at scale. So, given all of this, why hasn't open data as an ecosystem matured in the same way that open source software has? First, I think you can think about it from the perspective that open source software is born digital, right? It's low cost to replicate and improve. Obviously, has clearer IP frameworks. There already, even at the beginning, were pretty strong developer platforms, but definitely now. And I think one of the most important things that open source software benefits from is the fast feedback loops, right? It's very easy for people to contribute to the same code base and push that development faster because of that. Open data, on the other hand, has much higher ongoing collection and curation costs. It's complex in terms of rights, so whether it's copyrights or database rights, there's definitely privacy and liability constraints to contend with. And a big hurdle that doesn't really get talked about too much, but I think everybody realizes, is that open data has a tougher sustainability economic to solve for. So you think about the cost to maintain and keep data open in any form. That's much different picture than it is for open source software. So well, I think the value of open data is obvious. There's just not well-defined norms. Those have been really slow to develop around open data. So I wanted to dive into that for a minute and look at what I would consider like the language of open source software and why that matters. So here on the slide, just showing, in open source software, contributors share all of these things, right? Like a unit of work. So you have files of code, a tool chain. So things that people are very familiar with, whether it be Git or CI/CD. You have dependency models, packages, libraries that are part of that. You also have a governance norm. So people understand the concept of maintainers. They know who the maintainers are usually. You have issue triage, and you have well-established collaboration patterns. The fork, PR, review, merge. These are well-established. Even people that aren't fully involved in open source software kind of understand that concept. You also have a release model, so versioning, branches. These are clear, universal, translatable across domains, and really importantly, they're enforceable through tools. So you can use the same mental model whether you're in Python, Kubernetes, Postgres, because the primitives are the same. So what that means is thinking about it, code is self-contained, right? It's testable, it can be versioned, it's statelessly replicable. So let's try to translate that to open source data, open data, and see if there's maybe analogs. So for open data, who are the maintainers? I would bet that if you ask a group of people who the maintainer of a public data set is, you get a variety of answers. They might say it's the organization that produced it. They might say it's the owner of a data portal. They might say the community. They might say it's whoever last touched it. And the source of truth for data can live outside the repository. It can live in particular agency and upstream systems, in field surveys. Um, how do you fork a data set? There aren't any shared norms for when forking is appropriate, how divergence is reconciled, how attribution is preserved, how truth is decided. Um, but maybe versioning is more straightforward, right? So let's start with the question of what is a version of data? Is it a time slice, a change set, schema evolution? What's the semantic meaning of version increments? How do you reference entities across versions? How do you capture deletes? And one of my favorites, what's the unit of versioning? This is always hotly debated. Is it a record? Is it a table? Is it a data set? Is it a whole release package that includes multiple data sets and artifacts? How about data pull requests or merges? So open data rarely have reviewable diffs. They don't really have testable pull requests. Most changes to open data rarely even flow back upstream to the source. So thinking about that, that's a huge issue in terms of how you would bring data together. The bottom line is that truth in data sets isn't negotiated in code. It originates in external systems, in processes, in institutions. So I want to underscore that this is not a tooling problem. Open source software and open data operate on fundamentally different kinds of truth. That difference shapes everything about how they can be collaborated on, maintained, versioned, governed. So in open source software, the truth lives inside the system. Code is self-contained. The code base is the source of truth. A function either works or it doesn't. A test either passes or fails. The maintainer can declare what's correct code, right? So you can version it, you can fork it, you can review it in a PR. Its correctness is internally verifiable. So truth in software lives inside the artifact. Everything you know to judge the correctness is in the repo. That's why open source collaboration scales so well. Everyone's looking at the same self-contained object. In open data, though, the truth lives outside the system. It's not self-contained. So, for example, a building's height in a data set isn't determined by logic in that data set. A road's existence doesn't come from the schema, or a parcel boundary isn't true because it passes a test. The data set isn't the truth. It's a representation of the truth. And that's a key piece of, that's a key fundamental difference, really, between open source software and open data. Because that truth exists in a variety of places. It exists in the physical world, it exists in legal definitions, might exist in a government registry. We've all heard about authoritative data. It could exist in administrative processes. It could also exist in the obviously constantly changing reality around us. So the world is changing and that truth changes. So truth in data lives outside the artifact. And it means that everyone may necessarily need their own representation of reality, their own data set, even if it's similar to another existing data set out in the world. So from that, what we can What we can determine is that open data is not a single ecosystem, but a set of loosely connected domains. Loosely connected domains, it could be government, it could be research, it could be nonprofit. All these domains have stewards that all publish data openly, but rarely collaborate on the same data sets or share the same governance structures. Each of these domains might be healthy within themselves. So, you might have government portals that, their point of releasing open data is for transparency and compliance. You might have research data commons. They're really trying to enable reproducibility or maybe academic collaboration. Or you might have, nonprofit communities like Open Corporates or OpenStreetMap. They're really sustained through these open data sets with strong communities. But the connections between those are really weak, or had ad hoc, maybe not even purposefully connected. The ecosystem's open in principle, but not interoperable in practice. And so what this brings us to is something that I think is a good thing, which is the world is shifting towards data as infrastructure. We can't just think about access, but we have to think about connectivity, stability, governance. And how do you do that when you have so many different organizations that are disconnected and have different structures for dealing with this? So, really, what we should think about this as being is the next frontier for open data. The next frontier for open data is not more openness, it's a shared stewardship, it's interoperability. So, we've got to go into this post portal era of open data. And it brings us to what the mission of Overture Maps Foundation is. I mean, that's really it. This idea of creating a shared language for a geospatial data ecosystem. I'll talk a little bit more about that, but just to give you a little background for folks that are not familiar with Overture. Overture was founded in 2022 by AWS, Meta, Microsoft, and TomTom. Overture is part of the Linux Foundation, so folks working in open source software probably have heard of the Linux Foundation. One of the obvious goals was to reduce redundancy that was happening across those organizations in data creation and maintenance, and to share the cost. So these organizations were building a lot of the same things or very similar things, doing a lot of redundant work to do that. And of course, the cost is not insignificant, not just to build, but to maintain. So if you're trying to build something that's high quality, but also current, that's a pretty big investment, certainly for one organization. And so they came together to share resources to reduce that redundancy. Um, but it wasn't just about open data. The other thing that was really important was interoperability. To put together a way to make data more interoperable and create that shared language for the geospatial data ecosystem. So that shared language starts with a reliable, interoperable, open reference map. And what I mean by this is putting together something that can be openly referenceable, no matter who is looking at the data. So Overture brings together open data from a variety of sources. This could be member contributions, so data perhaps that member has maybe never made public, not because it's not open, but because they just didn't publish it. They may contribute that. We get data from, of course, government agencies, open map data communities like OpenStreetMap. And what we do is we bring all this together to create these foundational data layers for the themes that you see on this slide. And the focus for us is on coverage, completeness, and freshness, not on richness. And so that means we don't necessarily need a ton of really exquisite spatial detail or rich attribute detail. The reference map doesn't have to include the best representation of each feature or entity. It just has to have a representation that's as faithful as possible to what makes that feature unique. Again, the reference map has to act as a shared language. So what that means is if I have a building in my data set and you have a building in your data set, that reference map for Overture is supposed to be somewhat of a Rosetta Stone to say, we're both referencing the same building, even though our representations might look different or we might have different attributes. I'll also add that not all data are open, and not all data should be open. But an open way to reference spatial features globally is really important. So we have a reference map, which is great. You can use that reference map as just a reference map, or you can use that reference map as your data. There's a lot of organizations out there that still need a reliable data set, and it has nothing to do with referencing other information. But we do want to think about that reference map as a framework for interoperability as well, because even if you have organizations that don't need to link to other data sets, I think most people have discovered that that's really the key to being able to make decisions faster, better, really eliminating that cost and that time trade-off between urgency and fidelity of what you're trying to do. And so Overture's approach to this is the Global Entity Reference System, or what we call GERS. It's a little bit of an unfortunate acronym name. We will acknowledge that, but um, it's kind of stuck, and now we kind of like it. So how does this framework work? We've already established that Overture is about open data, but that's somewhat of a means to an end. There's certainly value in eliminating redundancy across organizations, sharing the costs associated with building and maintaining data, but that's only the first part of what we're trying to solve for. The big thing that we're trying to solve for is that interoperability. So what we do is we use an open ID system as a key part of this, and that's the GERS ID. GERS IDs are UUIDs, so randomly generated. They're unique, persistent IDs for real-world objects, and they're meant to be a reliable way to uniquely identify features in the reference map, anything from roads to buildings to places. So any data, no matter if it's open, if it's licensed, if it's private, it can be matched and linked to the reference map using GERS. So you might be thinking, well, that's neat, but an ID system isn't new. And you are absolutely right. There are some important parts of GERS that go just beyond IDs. Uh, the first is a change log. So the data change log tracks what's changed between consecutive releases of a reference map. And so one of the most important questions you can answer with this is what's changed for this ID in the latest release? And that might be an attribute change. That might be that that ID was deleted. It's important to know. It might be that a new ID was added to our data set. And so that's really a way to just say, you know, between the last release and the one I'm looking at now, what has changed? But it's not a complete picture, right? Because that's really just a single delta. What you really want to be able to have is a persistent way to trace back the history and the lineage of those IDs. And so we also have this GERS registry, which is essentially a comprehensive database of every GERS ID that was ever created. This is really important so that you can answer questions like, is this a valid ID? But it also has complete life cycle information for every ID. So um, again, being able to trace back the first instantiation of ID in the reference map, the last time it was seen in a release, um, the current location for an active entity, and any historical records for deprecated IDs. So again, it might not be in our reference map now, but if it existed, it will be in the GERS registry, and you'll be able to have that persistence and link back to it. And finally, there are bridge files, which I think are one of my favorite artifacts. We're bringing in a ton of new data sources constantly to improve coverage, quality, or freshness. And every time we bring in a new data source, what we don't want to do is just immediately merge it and just fill in gaps, right? We want to be able to build a pipeline that is really flexible to this idea of fitness for purpose. So it's not just about building a release that it's one size fits all, but how do we make a sustainable pipeline? And what we do instead is we have what we call the match store merge process, which as a new data source comes in, we match it to our existing corpus. So if there's a buildings data set that's coming in, and we also have, you know, billions of buildings already in our system. If there's new ones that we can't match, we'll assign them new IDs. And if there's ones that match existing features that we already have, we'll simply populate that GERS ID for those existing ones in the source data set. And so what we're doing there is ending up with pre-built mappings between GERS IDs and identifiers from other data sets. So this is really important because it's preserving that link as an artifact. So even if you don't want or need to use Overture's reference map, you can still benefit by linking data sets together via GERS. And so bringing this full circle, kind of put some clarity around what I've talked about and how open data can mature in the way that open source software has. A shared reference map gives us shared language. We can finally talk about the same places, the features, the entities, without translation layers. And I think also something that's important is that interoperability doesn't require uniformity, right? Every organization can keep its own models, schemas, representations, but still be able to connect to a common ID system. This again goes back to this idea of fitness for purpose, or authoritative data, or hey, I need this data because it's specifically referenced in my systems. You don't have to throw that out. Having global persistent open IDs makes data joinable, meaning like you don't have to do these complex spatial joins either. It's a table join. And you don't have to replace data. All of this data can exist if there's a need for it to exist. And it allows data owners to still have governance over their own data. Shared identifiers turn fragmented data sets into a networked ecosystem. And this is really important. Yes, unique identifiers are not new, but leveraging them in a way that actually networks this ecosystem together and makes the space between silos become a connective layer, not a void, is really key here. So data becomes infrastructure when it's referenceable across systems, across communities, across domains. It doesn't become mature by publishing more. It becomes mature by aligning what already exists. So has Overture figured it all out? Yeah, of course not. It's obviously a work in progress. There's a lot to do, but this is the closest solution I've seen in geospatial world that would get us to real interoperability and not just more open data. Um, Open data is great. I think through the course of my career, it's just been incredible to see how much more available data there is, whether it's open or not. But the frustration has been, how do you make the best use of that? And so this interoperability is really the key to that. We have a ton of really great contributors on this project, organizations that span government, nonprofit, private sector. And we're always excited when we have new people, new organizations join, because those new voices and perspectives are key to making sure that we're not just developing this and building this for a small group of organizations. We want to make sure that this really will help solve these interoperability challenges and help remove some of those silos. And so I'd love to hear from anyone in the audience today, talk more about open data and the Overture project. Absolutely reach out to me again. I wish I could have been there in person. I know I'll miss some great conversations after this, but again, if you want to hear more and have questions, I would always love to dive deep and get in the weeds about this. So feel free to reach out to me. Thanks.